Alright guys, welcome to today's class. Hope you guys have had a wonderful day. And let's get started with these questions. Let's start with this extra. Take a look at the nearest globe or imagine one. A woman at the North Pole looking for the shortest path to Quito, Ecuador. Just barely south of the equator would fly straight down the 78 degrees west line of longitude, then to fly to Gabon, which is a quarter of the way around the world to the east. She turns 90 degrees to face east, flies straight along the equator. She then returns to the North Pole by turning 90 degrees north and flying along another line of longitude, thus completing a triangular trip. She could begin repeating her trip by turning 90 degrees to the left, then flying to Quito again. At each stop, you should see that she must turn 90 degrees towards the next stop. But that's a total of 270 degrees in this triangle on the surface of the globe. How can that be? Well, this is just spherical geometry, right? It basically all comes from Euclidean's fifth postulate or something. If I remember it correctly, it's like Euclide's parallel line postulate. You can search it up. But what this postulate what made is because it's not that rigorous, not that easy to prove, and it doesn't make sense. It says that one line, and if there's another line going the same direction, they must not intersect. What if they do? And that's where these geometries come up. Like the geometry we're using is Euclidean geometry or normal geometry. Like basically no spherical, right? Like there's no such thing as a 90 degree, 90 degree triangle. Like this triangle right over here. Right? We don't have these triangles. But this is just a cool little thing. But let's get started with the next chapter. The perimeter of a closed figure is how far you travel if you walk along his boundary, right? So this chapter is basically covering perimeter area. So let's get started. Triangle ABC is equilateral. Find AB given that the perimeter of ABC is 36. Clearly, these three sides of this triangle are the same, which follows that each other side of ABC is 12. I was gonna have a try on 4.2. Find the perimeter of DEF, and you get in two angles and one side. Alright? I was gonna have a try on this question and tell me to the chat. All right, let's get started with this question. So, how do we bother to approach this? Well, one way is to see that this is 60 degrees since this is a 90-degree angle. And from our knowledge of 60, 30, 60 triangles, remember we talked about last chapter about equilateral triangles and how if we split it in half, this side would be 2 times this side. And then we can find this is square root of 3 times that side. This is the main side. We can similarly apply this knowledge to here. As we notice that this 30 degrees goes there, 60 degrees goes there, and the 60 degrees is the square root of 3 part, right? And we notice that this is basically an isosceles triangle, since the base angles are the same. So this splits it in half, alright? This entire thing is getting split in half. So this is going to be 4 square roots of 3, which implies that this side is 4 or this is 8. Or it's pretty easy to see that 8 because it's isosceles. But anyways, from here, adding all this all up gives you 16 plus 8 square roots of 3. Remember, this is 8 square root of 3. This is the total side length. And that's our answer. Alright. Now let's say if you have a triangle 4.3. Even though it's a bit easy, there's a very cool trick on how to count these. Alright? Let's get over trying this question and tell us to chat. Tell me if you can find the cool trick. Alright? All right, let's get started with this question now. So basically, instead of counting it by hand, like one, two, three, four, five, and messing up somewhere in the counting, we'll use a much smarter technique, all right? Let us complete the rectangle. Why is there a rectangle? We can complete it, right? The important thing is that perimeter doesn't matter. The perimeter, if you change the shape, for example, if you change this side into, I'll highlight this in like pink. If you change this side in pink into this side in green, it doesn't matter. They're the same length. So the perimeter does not change. It's much more easier to count a rectangle than some figures mashed up together. It's so much easier since we know the formula. Similarly, you can do the same thing over here. This side length is the same as this length. Don't trust me? Watch. Pink, these two match up, alright? So if you want to prove it to yourself, this is the way. This also matches up. Match up the side length with the parallel side. Vertical with vertical, horizontal with horizontal. It clearly works. Now, this entire thing is just a rectangle now. It's so much easier to count instead of counting it one by one. Like one, two, like for example, if I just count it one by one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm about to mess up somewhere, right? I might be over counting or under counting. Alright? So from here, since we know the formula for how to count the perimeter of the rectangle, which is just 2 times length plus width, plug in the values. Well, this side length is just 8. This side length is 5. Plugging it in gives 2 times 13, or 26 as our final answer. And it checks out. 26 is indeed our final answer. Anyways, let's move on to 4.1.1 exercises. In the diagram below, xy is equal to 5 squared root of 2, y z equals 10, and y is equal to z is equal to 45 degrees. Find the perimeter of xyz. I'll let you guys know try this question in 10 minutes through chat. All right, let's get started with this question now. So we noticed that y and z are both equal to 45 degrees, which implies that this is isosceles triangles. So this is 5 squares root 2, adding up because 10 plus 10 squares root 2, and that's our perimeter. Right? Now we have 4.1.2. Triangles ABC, AE, and EFG are below are all equilateral. Points D and G are midpoints of AC and AE. If AB equals 4, what is the perimeter of the figure ABCDEFG? And this is from the ANCA. I was gonna have a try on this question and tell me after chat. All right, let's get started with this question now. So it's not 21. And the reason why is because we're not counting four triangles. Remember, it's the perimeter. And we're looking at the polygon. In reality, it looks like this, all right? Oops. This is reality looks like. It's not 4 times 3 is 12, 2 times 3 is 6, and then 1 times 1 is 21. 1 times 3 is 21. And then we add it all up, that's 21. Nope, it isn't. Because in reality, the figure actually looks like this. And clearly, this is going to be a 4, 4, 2. This will be a 2. This is a 1. Obviously, I don't have it to scale. And that's probably it. Because you can split it up to a triangle. Adding all this up, that's 8 plus 4 is 12, plus 3 is 15. So the answer is 15. Right, so basically, it is not three triangles added together because we want the perimeter of the polygon ABCDFG, not the perimeter of the three triangles added up together. So this is kind of tricky, alright? Try to read the question carefully and see what you're missing, alright? Now I'll start with 4.1.3. Must two congruent triangles have the same perimeter? Why or why not? I was gonna try this question and tell my answer to chat. All right, let's get started with the A, B, and C. Now, for A, must two congruent triangles have the same perimeter? Yes, because all three sides are the same, so they all obviously add up to the same value. B, must two triangles with the same perimeter must be congruent? Why or why not? No, because we could have 3, 5, 7, for example, and we could have one 7, 7, for example. And that clearly are not congruent triangles. So this is no. This is yes. And must two triangles with the same perimeter must be congruent if the triangles have one angle measure in common. Hmm, that's a more interesting one. How do we go for that? Well, we gotta do it by SAS or AAS. Clearly, that's not gonna be true. No, that can't happen. So how does that work? Because in reality, they can have the same perimeter, but we can actually change these side lengths. All right, like this. You see this? That could have the same perimeter as that one. This is not to scale, but the angles are indeed same. Perimeter is the same, but they're not congruent. So this is also a no. All right, now let's move on to 4.1.4. This is a bit more tricky. All right, I'll just have try on this question and tell Mr. Chat. All right, let's get started with this question now. So, how do we come to approach this? Well, we can't use the same trick as we did before. Well, we can, but it'll be very hard to implement because of this extra three, right? So let's start and make the entire rectangle again. This side goes to this side. And on this side, we have these sides which go up and this side. So we're left with these extras. All right. And what's the perimeter of that? That's 1, 2, 3, 4, 5, 6. And the side length is going to be 9. So I'll be 6 by 9 or 30. And from here, afterwards, we have these three extras, right? Added this up, that's 36. So we actually had to kind of modify our first approach. Now we used a small trick. We still have to modify it because this has overlaps now. Before, this one didn't have any overlaps, alright? So it's much more easier to implement. Anyways, let's get started with 4.1.5 now. Triangle with perimeter 45 has one side that is twice as long as the shortest side and another side that is 50% longer than the shortest side. Find the length of the shortest side of the triangle. How do we come to approach this? Say we have this random shortest side, alright? Let's say this is shortest. This is going to be 1.5 times the shortest. It's 2 times the shortest. Now we add them all up with in terms of shortest. Add them all up, we get 4.5 times the shortest side is 45. Simplifying yields 4.5 times the shortest equals 45, which yields 45 divided by 4.5 or 10 as our final answer. So 10 is our final answer. This is just basically algebraic manipulation. Alright, so let's move on to the next lesson real quick. Area. I will just keep it brief because we don't have a lot of time left. So what is area? Area is just basically the amount of, well, how much space does it occupy within a certain area? Yeah, I'm using area again. Yeah. So it says roughly speaking, it's just the amount of unit squares needed to fill a certain object or figure, or the amount of space it covers, or amount of space the figure covers. Alright? For example, a square. Say this has side length 4, then the amount of space it covers is 16 units. Alright? Of whatever unit the side length is in. Alright? This is just examples of how to use area, right? We know an area of a rectangle, we know an area of a square, we also know areas of triangles, we know a bunch of areas, and also areas of trapezoids. For a quick example, this is also a good example. A right triangle, well, this is half a rectangle, technically. Because you can extend this, these are going to be parallel. This is also 90 degrees, so all of this is 90 degrees. And then you can see that this is half a rectangle, so it's 1/2 base times height. You can also do this. You can also use this to show that all triangles are basically half of a rectangle. And you can use that to derive that it's 1/2 base times height. This is the base, or this is the base in this case. Base. This is height. Alright, and we're asked to find the area. That's going to be 4 times 6, 24. Divided by 2 is 12. And that is indeed correct. And that is going to be the formula of the right triangle given its length of the sides. Or 1/2 by each times height. Anyways, that's it for today's class. I hope you guys have a wonderful weekend, and I'll see you next week. Bye!